So this is a quick recap review of the exponent rules and patterns that we've been working on so far. And we've worked on the product, quotients, negative, and zero property rules for exponents. And so we've got a couple of quick example problems just to review before you do your practice for today. So in our first expression, we have negative 5x to the negative third power. And here we see that we have a negative exponent. And we have to remember that it's only belonging to the base of x, right? So this is belonging to the base of x. And that's telling us that that's in the wrong location. That really belongs in the denominator. So our numerator should have negative 5, and our denominator would now have x to the third. And at this point, you would look to see, do you have any greatest common factors to divide out from the numerator and denominator? We don't, so this would be our simplified format. Negative 5 divided by x to the third. Now, as you look at your second expression, we have the quantity negative 4x raised to the negative second power. And so this is different than our first one, where the negative 2 belongs to the entire base of negative 4x. And it's saying that this negative 4x is in the wrong location. It really belongs in the denominator. And we'll have two sets of everything that's inside the parentheses. So I'm going to rewrite the denominator, what should be there, the negative 4x. And now I have two sets of what's on the inside, which means I have two sets of 1's being multiplied in the numerator and two sets of negative 4x being multiplied in the denominator. So we just have to simplify that. And we know 1 times 1 is 1, and that's in our numerator. Our denominator, we can do the negative 4 times negative 4, which would be 16. And we've got two x's multiplied together, which can be shown as x to the second. So our simplified expression should be 1 divided by 16x to the second. And again, remember, if you were typing this into class kick, what you would do is you could put a parenthesis around the 1, divided by a parentheses, you've got your 16x to the power of 2, and close that parenthesis to show that all of that is in your denominator. Now, if you look at your next example, we want to simplify x to the 7th, x to the negative 3rd, y divided by y to the negative 2nd. And we did give you a couple of multiple choice answers options to kind of match and see if you were on target. So as we're looking at this problem here, again, you're going to look to see, is everything in the right place to start with, and then can we start working on simplifying from there? And if you notice, we have a couple of things in the wrong location. We have an x to the negative 3rd in the numerator, which really belongs in the denominator. And we have a y to the negative 2nd in the denominator, which really belongs in the numerator. So we're going to rewrite everything in the correct location and work on simplifying numerators and then denominators. So if we look at our numerator, we've got x to the 7th, y to the 2nd, y. And remember that y has raised to the power of 1. It's implied. So we see we have some y's that we can simplify. We have 3 y's in the numerator. So let's rewrite it as x to the 7th, y to the 3rd divided by x to the 3rd. So our y's are all simplified in the numerator. Now if you notice, we have x's in the numerator and x's in the denominator. We have 7 x's in the numerator and 3 x's in the denominator, which means we have some greatest common factors we could divide out. We can divide out x 3 times from both the numerator and denominator, leaving 4 x's in the numerator being multiplied together. Well, that would be denoted by x to the 4th in the numerator, and then we have the y to the 3rd in the numerator. And the denominator is 1, and we know we don't typically write denominators with 1, so that's how we're simplifying to get x to the 4th, y to the 3rd to match with your answer option for A. To look at your last example, we're kind of putting everything together here. And as we look at this, we can see right away that we have 4 sets of the numerator, and we have something in the denominator that doesn't. Let's work on simplifying the numerator first, rewriting where the denominator part belongs, and go from there. So if we have 4 sets of, we now have 256 s to the 16th divided by 2 s to the negative 3rd. And again, we said that s to the negative 3rd really belongs in the numerator, so let's rewrite that in the right location and see what simplifying can happen now. Well, we have 16 s's and 3 more s's, so that means there are 19 s's in the numerator. Now we want to look at the coefficients to see if there's any greatest common factors that we could divide out. And 256 and 2, has a greatest common factor of 2 that we can divide out. So if we think of it that way and we divide out that greatest common factor of 2, we're left with 128 s to the 19th. So that was a quick recap of your exponential rules that we've been working with so far, and you'll continue using those as you work on your practice problems for today.